Okay, so problem 19.3. Calculate the potential of the following cell. This is the description of the cell in the shorthand expression. And indicate the reaction that would occur spontaneously if the cell were short-circuited. So this expression, this is the shorthand expression, states that there are two compartments indicated by these two bars, and there is a salt bridge. The iron is on the right side, while uranium is on the left side. Both sides of the cell has same electrode. There is a platinum electrode. Okay, so according to the reduction potential, if you have iron, okay, these are the two half reactions. Iron is being reduced to iron 2 basing on the given. And the electrode potential for this one is positive 0.771 volts. The other half reaction for the uranium, this is the standard electrode potential of this given equation. Now you will notice here that this is also reduction. Okay, from dioxouranium, take note that this is oxygen. You have two atoms and the charge of oxygen is -2, so this becomes -4, and you have a charge of +2. So the uranium here must be +6. Okay, +6. So you have +6, then -4, that is equal to +2. So from +6, it becomes +4. So it is being reduced. So again, take note that the standard electrode or the electrode potential is also known as the reduction potential. So the equation is always in it is under a reduction reaction. Okay. To solve for the cell potential, so again we have the cell potential is equal to the electrode potential on the right side minus the left side electrode potential. So we have to solve first each electrode potential, the right side and the left side. So again, the right side is for the iron. So we have the Nernst equation. You have the standard electrode potential minus 0.0592 over n, that is the number of electrons, times the logarithm of the product of the products over the reactant. So we have here iron +2, so that is the product, over the iron +3. Plug in the given values. So this one is the standard electrode potential for the half reaction of iron. And for the concentration of iron +2, it's 0.01, it's given. And the concentration for iron 3 is 0.025, it's given. So computing this value here, this value is -0.02356, and you get the difference, so that is 0.7946. So this one becomes positive. So you have 0.7946 volts, that is the potential at the right side electrode. For the left side electrode, so same times the logarithm of the product over the reactant. So again, for this reaction, you have uranium +4, that's the product, over the product of the reactants, you have the dioxouranium, this one, times the hydrogen ion raised to the power of 4, since there are 4 moles of hydrogen ion. Plug in the given values for the standard electrode potential. For this reaction, you have positive 0.3346. For the concentration of uranium ion, that is 0.2, given here. And for the concentration of the dioxouranium, that is here, 0.015. And for the concentration of the hydrogen ion, that is 0.03. Manipulate your calculator. So this value here, this value is 0.2 0.2136 positive. Get the difference, 0.334 minus 0.2136. So you have 0.1204 volts. So the cell potential would be equal to the electrode potential on the right side minus the left side electrode potential. So we have here the cell potential, which is 0.6742 volts. Take note, you have a positive sign, so therefore the reaction is spontaneous. So what will be now the equation that is being asked? Indicate the reaction that would occur spontaneously. So we have here, so it is correct that the iron is in the right side, so that is reduction. So for the equation, you will have here the equation for the iron plus 3, then you will have 1 electron, then it is being reduced to iron plus 2. Okay? But for the second half reaction, this one, take note that this is also reduction, but it is on the left side, so it must be being oxidized. Right side reduce, left side oxidized. So we will reverse the equation. So this is the other half reaction. So you have uranium plus 4, then you have 2 moles of water, and you have the dioxo uranium, that is plus 2, and 4 hydrogen ion plus 2 electrons. So when you get the net equation, take note class, in our Gen Chem for the redox reaction, you have to cancel out the electrons. So take note, in this half reaction for uranium, there are 2 electrons, while in the other half for the iron half reaction, there is only 1 electron. So in order for the electrons to cancel out, so you have to multiply this one by 2 in order to cancel out the electrons. So this becomes 2 electrons, you can cancel out the electrons. So iron now becomes 2 moles of, the net equation now is you have uranium plus 4, or we can write first iron. So you will have 2 moles of iron plus 3, and just get the sum. You have uranium plus 4. Take note that uranium here from plus 4 to this one is plus 6. This one is plus 6. If you are going to check it on using your oxidation number. So it is being oxidized. Plus 2 moles of water, and the products are, you have the iron, 2 moles of iron, and 1 mole of the oxo uranium plus 4 moles of hydrogen. Electrons, 2 electrons will cancel out. Then you check if you have a balanced equation that is in our Gen Chem. Take note of the charges. If we have balanced charges, you have 4 plus 2, 6 plus 4, 10. You have 6 plus 2, 2 times 3, 6 plus 4, 10. So that's balance. So this is now the equation that is being asked. Indicate the reaction that would occur spontaneously if the cell is being short-circuited. So since again we have a positive value for the cell potential, so basing from the sign convention that the right side is reduction, so it is the iron that is being reduced, and of course the other one would be oxidized. So it is the uranium that is being oxidized. So we'll have to reverse the equation to get the net equation. So this is now the net equation. That's problem 19.3.